All right, the test for convergence that we're going to learn today is called the nth term test for divergence. It's important to know that this is a test for divergence in particular. There are going to be some nuances we have to pay attention to on this one. So we start off with some theorems. The first theorem says that if a sum converges, then the limit of its terms must approach 0. So that's kind of intuitive if you think about it. If these terms, the terms that are within the sum, are not shrinking and getting to a smaller value closer and closer to 0, then it would be impossible for the sum to reach a final value. Okay, and then the contrapositive of that is true, not the converse. That's important to know. The contrapositive means you switch the order and negate both statements. So we start here and say if the limit does not equal 0, then the sum does not converge or diverges. So the converse of what we had up here would be saying that if it converges, then the limit does equal 0, or if it diverges, then the limit does not equal 0. And that's not what it says. We can test if the limit does not equal 0, we can definitively say that it diverges. So a little bit more information over here. So if you find that the limit does equal 0, you cannot use that to conclude that the series converges. That would be the converse of our original theorem. So we're just going to go through 4 examples. We're going to simply talk about whether or not they converge or diverge. That's our goal for today. So looking at number 1a, we have the sum from 0 to infinity of n over n plus 1. Our nth term test is where we take the limit as n approaches infinity of our expression. That expression is a polynomial over a polynomial. They have equal exponents or equal power, so we use a fraction of their coefficients and just get 1. Since 1 is not equal to 0, we can say that this diverges by the nth term test. Okay, example 1b, again we have our summation, so we switch that to the limit as n approaches infinity of 1 plus 3 to the n over 2 to the n. So we've not done very many limits with an exponential function as a fraction, but if we think about n getting very large, these exponents getting very large, the 1 would be insignificant pretty quickly. So we really can think about this as just the limit as n approaches infinity of 3 to the n over 2 to the n, or even simpler, the limit as n approaches infinity of 3 over 2 to the n. That limit would be approaching infinity because this value is a number bigger than 1. So like the geometric series we learned yesterday, this would diverge. Okay, C, we sum from 1 to infinity of 1 over n. So take the limit as n approaches infinity of 1 over n. That is a bottom-heavy function, so that limit would be 0. So remember this rule over here. Saying that the limit approaches 0 does not necessarily mean it converges. It may converge, but we cannot use that information to validate. So we have to say that our nth term test is inconclusive. We will, in the next few days, learn ways to know if this converges or diverges in other ways. For now, all we can say is we're not sure. Okay, and our last one, the sum of n cubed over n factorial. When we take the limit as n approaches infinity of n cubed over n factorial, that's kind of hard to say if it's equal power, top heavy or bottom heavy. This is actually bottom heavy. And the reason for that is because if we go any higher than the number 3, our n factorial would have a higher power than n cubed. And we're talking about going out to where n equals infinity. So it would not take long for n factorial. It would eventually dominate over n to the third because we're taking n to infinity. So we would have an infinity exponent in the bottom. So again, since our limit approaches 0, the nth term test is inconclusive. Okay, you'll follow this lesson with your skill builder, where you're determining if series converge or diverge, or if it's inconclusive based on the nth term test.